Welcome to The Explainer. Today, we're going to talk about curves, but probably not the kind you're thinking of. We're talking about how a simple bend in a mirror or a piece of glass can literally flip your world upside down, change sizes, and even, get this, start a fire. You know that little warning, right? The one on your car's side view mirror? Objects in mirror are closer than they appear. We see it all the time, but have you ever really stopped to wonder why? What's going on there? Well, the answer isn't some weird automotive magic. It's all about how a simple curve can totally play with light. Okay, so first up, let's talk about mirrors. We're going to see how just a tiny curve can take a regular old reflection and twist it into something totally different. Sometimes warped, sometimes huge, and yeah, sometimes even upside down. This whole thing probably rings a bell, right? Like if you've ever been to a science center or one of those old school fun houses with the wacky mirrors. But what's really cool is you don't need any of that stuff to see this effect. You can actually do it right now, just by heading to your kitchen. No, seriously. Go grab a shiny spoon. Got it? Okay. Look into the inside part, the part that you'd scoop soup with. What do you see? Your reflection is completely upside down. Wild, right? Now flip it over to the bulging, rounded back. Bam! You're right side up again, but you look kind of small and stretched out. That one simple spoon is showing you everything you need to know about the two main types of curved mirrors. So what you just saw isn't magic, it's actually just geometry. Your spoon is basically acting as something we call a spherical mirror. Just picture a giant, hollow, reflective ball, like a Christmas ornament the size of a building. Now, if you cut a piece out of it, that piece is going to be curved. And whether it curves in or curves out, well, that's the secret to the whole trick. All right, so let's get a little more technical and put some actual names to what we just saw with the spoon. We'll break down exactly what's happening on each side. It really all comes down to which way the curve is going. That inward curve, the bowl part of the spoon, that's a concave mirror. Think caves in. That's the one that flipped you upside down. And the outward, bulging curve on the back, that's a convex mirror. That's the one that made you look smaller. See? Concave and convex. Two different curves, two totally different results. So where do we actually use these things? Well, anytime you need to zoom in or focus light into a single spot, you're going to use a concave mirror. Think about your dentist, right? They use a tiny one to get a super magnified kind of scary view of your teeth. Or look at a flashlight. That shiny bowl shape behind the bulb is a concave mirror, and its job is to gather all that light and shoot it out in a powerful beam. And this brings us right back to our first question about the car mirror. The reason it has that warning is because it's a convex mirror. It's designed to give you a really wide field of view so you can see more of the road and any cars in your blind spot. To do that, it has to shrink that big picture down to fit in a little mirror. The side effect? It makes everything look smaller, which our brains interpret as being farther away. And mystery solved. Okay, so we get what they do, but the real question is how? How does a simple curve do all this crazy stuff? Magnifying, shrinking, flipping you upside down. It seems complicated, but it turns out all of this is controlled by one single, beautifully simple rule. So before we get to the rule, let's just get our terms straight. The light that hits the mirror, we call that the incident ray. And the light that bounces off, that's the reflected ray. Incident and reflected. Got it? Now this is where it gets really cool. Look at this table. The angle of incidence is the angle the light comes in at. The angle of reflection is the angle it bounces out at. Just look at the pattern. 30 degrees in, 30 degrees out. 45 in, 45 out. 60 in, you guessed it, 60 out. They're always the same. This is it. The big secret. The angle of incidence always equals the angle of reflection. We just write it as I equals R. That's it. This one little rule is the law of the land for reflection. It doesn't matter if the mirror is flat or curved. This law holds true for every single ray of light, every single time. It's the master key that explains everything. So what does this I equals R rule actually mean for what we see? Well, on a normal flat mirror, it's pretty straightforward. If you have a bunch of parallel light rays coming in, they all hit the flat surface at the same angle. So they all bounce off at that same angle and they stay parallel. Easy peasy. But what happens with a concave mirror? Now, those parallel rays are hitting an inward curve. So each ray hits the surface at a slightly different angle. The I equals R law still works perfectly for each individual ray, but because the surface is curved, the law forces them all to bounce inwards toward a single spot. They converge. That's the secret sauce. That's how a concave mirror can focus light. And you can probably guess what happens with a convex mirror. It's the exact opposite. The parallel rays hit that outward curve, and the I equals R law makes them all bounce away from each other. They spread out or diverge. And that's how your car mirror works. It takes in a wide view and spreads the light out so it can all fit in that little space.
Okay, so everything we've talked about so far has been about light bouncing off things, reflection. But what happens if light can pass through the curved object? Now we're entering a whole new world, the world of lenses.
Have you ever seen a drop of water on a newspaper or a book? The letters underneath look bigger, right? That little dome of water has a curved surface, just like our mirrors. But instead of reflecting the light, it's letting the light pass right through it and bending it in the process. That little water drop is a perfect, simple lens. And really, that's all a lens is. It's just a piece of see-through stuff, usually glass or plastic, that's been shaped with very specific curves. Its whole job is to take light that passes through it and bend it. The scientific term for that bending is refraction. And just like with mirrors, we've basically got two types. A convex lens, one that's fatter in the middle, brings light together. It converges it. But wait, notice something? A convex lens does the same job as a concave mirror. And a concave lens, one that's thinner in the middle, spreads light out. It diverges it, just like a convex mirror. The names and effects kind of flip, but the core ideas are exactly the same. And this ability to bend light, it is everywhere. It's what makes eyeglasses work, it's inside your smartphone camera, it's how telescopes and microscopes show us things that are impossibly far away or incredibly tiny. Lenses are fundamental to how we see the world. And, the most amazing lens you'll ever own is the one you're using right now, the one inside your own eye. And let's not forget how powerful this can be. Remember how a concave mirror focuses all that light into one tiny point? Well, sunlight isn't just light, it's also energy. It's heat. So if you use a concave mirror to focus sunlight, you're focusing all that heat into one spot. And yeah, you can absolutely concentrate enough energy to set a piece of paper on fire.
So it all comes back to a simple curve. Whether you're bouncing light off it with a mirror or bending light through it with a lens, that curve gives us the power to control light with incredible precision. And that really makes you think, doesn't it? If a simple curve is all it takes to see across the galaxy, or to fix our own vision, or even to start a fire with nothing but sunlight, what other incredible things are out there just waiting for us to figure out a new way to bend the light?